Welcome back to my channel. In the last class, we have been discussed the stability factor for all the three biasing techniques. In this video, we'll see the stability factors problems. So this is a question asked like 3 to 4 times. You can see this question. Actually, in this question, he was asking to find the stability factor and then Q point and collector to emitter voltage. That is, we have to find IC and BCE, which is Q point actually, Q points. So this is what we have to find out, and at the same time, he was saying that it is given in a biasing arrangements. Whenever he was saying that self-biasing arrangements is nothing but self-biasing is nothing but a voltage divider bias. Self-biasing is nothing but a voltage divider bias. So first of all, we have to draw the circuit diagram. How to draw this circuit diagram? We already know this, right? We have to draw the circuit diagram for voltage divider bias. So here, let me draw the circuit diagram here. And this one RB, and then this is one RC, and then here it is R1, and then R2. This is connected to the ground. From here, we are connecting it as a VCC, right? This is the circuit diagram. So from here, we can find the collector current of IC, he was saying. How to find the collector current of IC? This IC current is approximately equals to beta times of IB, right? So how to find this IB here? Already we can get the standard expression, right? Let me try to find this base current of IB. By doing KVL and all, this IB will get VThevenin minus VBE by RThevenin plus 1 plus beta times of RB. This is the direct formula. Otherwise, this is the right. Actually, this is the right formula. You have to remember. Otherwise, just do the KVL and then you'll get an expression. Now let me try to find this, substitute this VThevenin value, but we don't know the VThevenin value, right? So for that case, we have to find this VThevenin value. Then VThevenin's value will be equal to VCC into R2 divided by R1 plus R2, right? This VThevenin VCC value, how much was given? VCC value is 20. This 20 into, and then R2 value he was given as R2 value is 5, and then 5 divided by R1 value is here he was mentioned R1 value is 100, that is 100 plus 5 will get it. So if you solve this one, we'll get somewhere around 0.952. That is VThevenin's value. And at the same time, let me try to find the RThevenin also. That is R1 is in parallel with R2 actually. That is R1 into R2 divided by R1 plus R2. Alright. This R1 value will be, here it is given as the 100. 100 into, and then R2 value is given as 5, I think, right? 5 divided by 100 plus 5. If you solve this one, you'll get somewhere around 4.76, you'll get it. This is kilo ohms. Now, let me try to find this IB. This IB value will be equal to VThevenin, that is 0.952 minus VB. VB value for which one is this one? This one germanium. For the germanium, what is VB value? That is cutting voltage is 0.3. That is, you must remember. For silicon, 0.7. Here it is germanium, so that is why here I am writing this as 0.3 divided by RThevenin's value. RThevenin's value is 4.76. 4.76. And then beta value is how much? Here the what is the beta value was given? 50. So 1 plus 50 into RE value. how much RE value he was given. RE value is 0.1 kilo ohms. 0.1 kilo ohms, that is 0.1. If you solve this one, then we'll get this IB as 66.1 microamps will get it. Now I got it, this IB. By substituting this in IC expression, I will get the collector current. That is beta into IB. That is beta value is equal to 50, and then this value will be equal to 66.1 into 10 to the power of minus 6. By solving this one, the collector current you will get it as 3.38 milliamps. This is the approximate collector current I will get it. This was the collector current I will get it here. And then how to find this emitter current here? Already we know that the expression of IE will be equal to IC plus IB, right? The expression the expression of this one will be equal to IC plus IC plus IE, which is approximated to IC plus IB, which is approximated to again IC only. So emitter current of IE is also approximated to 3.38 milliamps. Like this we can get it. And one more thing, if I try to find this VC, how much this VC is means this one. This is the collector voltage. This at this point, this collector voltage will be VCC minus IC into RC, right? What is the voltage across this terminal? Across this terminal, if you try to find this voltage, then what it will be the total voltage VCC minus the drop voltage across this terminal. That is VCC minus IC RC. That is VC. So here the VC I'm writing as VCC minus IC RC. Let me substitute directly. VCC value is 20 minus IC. IC I got it 3.38. 3.38 into RC value. RC value, how much it was given? It was given the 2. If you solve this one, you will get 13.38 volts. This is VC algorithm. So by using this one, again, we have to find actually VCE, right? For that case, we have to know VE also. This VE value will be equal to IE into RE, right? IE is approximately equal to IC only. That is 3.38. And then what about RE value he was given? RE, how much he was given? RE value is where it was 0.1. RE value is 0.1. Let me substitute here. It is 0.1. It will become 3.38, I think. Sorry, 3.38 into 0.1 means 0.338. 0.338 volts. This is the VE. By using these two, I can find VC. But because VC value will be equal to VC minus VE, right? I'm doing the same thing here. VCE value is equals to VC minus VE, right? So let me substitute that. What is the value of this VC? 13.38 minus 0.338. If I do that one, I'll get this VC value is equal to 13.04 volts. This is VC, and I got IC, that is 13.38 milliamps, and VC is equal to 13.04 volts. That is Q point is completed. Now how to find the stability factor? We have to remove the standard formula, and that is 1 plus beta times of R Thevenin plus RA divided by R Thevenin plus 1 plus beta times of R, right? If I substitute all the values, then you will get the stability factor is 25.149. Like this. This is very, very important problem. Maximum you can see this kind of problem in the final exam. Just this is the second problem. Here, in this case, he was saying that given circuit is a fixed bias. That is a fixed bias. For this one, we have to find the operating point and stability factor. So he was saying the operating point. Operating point means Q point. This Q point, what it will be there? IC and VC. Again, we must find IC and VC. After this one, we have to find the stability factor of S. What is the stability factor S of fixed bias? It will be equal to 1 plus beta actually. It is very simple. It is 1 plus beta means 1 plus 50, which is 51. This is computed very simple. This is the stability factor for fixed bias. But we have to find the stability factor for, we have to find the Q point for this fixed bias. Let me try to draw the diagram for this fixed bias, which it looks like this was in an RC, and then here I'm connecting it to ground. Fixed bias now. Like here you have to give RP. This is in a BCC, like this. So if you see this one, we already know the standard expression, that is IB is equals to BCC minus VBE divided by RB. Like this will get it. This BCC value is equals to how much was given, that is 9. BBE value is equals to 0.7 divided by RB value is equals to 3. So if you substitute, if we do try to calculate this one, then I'll get 1.0375 milliamps. I'll get it. Right? This is the value of IB. So, but here if you try to find this IC, then it will become I beta times of IB. This beta value will be equals to 50 into 1.0375 into 10 to the power of minus 3. If we do this one, I will get 51.875 milliamps. Actually, this 51.875 milliamps is a very larger current. Actually, we cannot expect this much amount of larger current in the BJT. It means this transistor is in saturation region. We have to find the maximum collector current in this case. So how to find this maximum collector current? Maximum collector current will be equals to BCC by RC number. See, this is the collector current. This was the collector current means BCC. VCC by RC, we can get it. VCC by RC. Again, we can substitute these values over here. That is VCC is equals to 9 and RC value is equals to 3 kilo ohms. Then this value is equals to 3 milliamps. It means that whatever the collector current I got it, that collector current is greater than this IC maximum, which is not even possible in the BJT. It means this BJT is in saturation region. This is the condition we must get it. If this collector current is lesser than this IC maximum, then whatever the expression we got it, that is perfectly right. But right now I got this collector current IC is greater than this IC maximum. So that is why whatever the expression we got it, that is wrong. That is transistor is in saturation region. This is what we can conclude it. Now you see here, if this is an expression now, if this transistor is in a saturation region, then how to find this collector current? This collector current we can find with VCC minus VCE saturation divided by C. By using this expression, we can find collector current. Simple enough. VC saturation like this one. If you see here, this is the collector current, right? This is the collector current. This is VCC, and here it is the voltage will be VCE saturation. So collector current of IC is equal to VCC minus VCE saturation divided by RC. By using this expression, well, we can find it. Then this IC value will become VCC value is equal to minus, and VCE saturation value will be equal to 0.2 actually. Did he given in the question? No, it was not given. So by default, VC saturation will be equal to 0.2. If you was given something, then you can consider that value. Otherwise, you have to consider by default value is 0.2. Divided by RC value is 3, and by doing these values, we'll get 2.93 milliamp. This is the correct amount. Now, we already find it this VC, I think. We haven't found it this VC. Yeah, VC is already 0.2 volts only. Why? Because it is in saturation region. So IC, comma VCE value will be equal to how much? 2.93 milliamps, and VC value is equal to 0.2. This is one of the expression we find it, and the stability factor is one of the expression we find it. In this way, they will ask you the questions in the final exam. Just go through it once. Thank you.